In this lecture, we will talk about camera, lighting, and rendering. First, let's start with camera. If you want to read more about how the camera works within Blender, there is really good documentation on the blender.org website. You can use this link to access those documents. Let's talk about lens focal length. Wide-angle lenses are typically between 12 and 36 millimeters. These will capture more information, but there will be a lot of distortion toward the edges of the frame. Portrait lenses tend to be 36 to 80 millimeters, and this is more appealing for faces. Not too flat, not too distorted. Telephoto lenses tend to be really flattening to the subject matter, but it's the only way to capture certain types of things that are really far away. Sensor size allows you to capture information that comes in through a lens, meaning the larger the sensor, the more of the light coming in through a particular lens that's captured. A small sensor will capture less of the incoming light coming in through a lens. Another thing to think about is depth of field. And so depth of field is controlled by the aperture and essentially is responsible for that foreground or background blur that you might see in certain photographs or in film. Sometimes you'll see that blur or lights within that blur shaped in a certain way, and that's called the bokeh. So if you have a star-shaped aperture, the lights in the background might appear to be star-shaped. We also have things like shutter speed and ISO, and ISO refers to film sensitivity, and shutter speed is essentially how long a recording medium like film is exposed to incoming light. So here you can see a common focal length chart, and with the associated subject matter that goes with each group of focal lengths. These aren't necessarily hard and fast rules, they're just kind of common things you might see. So on the right hand side of the chart, you have objects that are very far away, a super telephoto lens at 400 millimeters, very narrow field of view at 6 degrees, versus the opposite side, which is a wide angle lens at 14 millimeters and 140 degrees field of view. And those would be things like architecture, landscapes, interior rooms, and groups of people. And then you can see the other common focal lengths for the other subjects. In 3D software, we want to be able to frame the subject matter. And to do that, we use the viewport frame to show us a preview of what will be inside the field of view. You can also enable safe areas, camera guides, and those guides might be something like the rule of thirds or the golden ratio, certain diagonal lines, and these are just to help you line things up as you're laying out a scene. Some tips to avoid creating awkward images: don't crop at the joints of characters. And if you have characters that are interacting, try to avoid cutting more than 180 degrees between the characters. So here are some typical camera shots you might experience in film and for your own animations. Things like an establishing shot, which will give you an overview of a scene, a wide shot, a medium shot, which tends to be a torso and up of a character or a couple characters, a close-up, which is chest to head, extreme close-up, which is the face, and a super extreme close-up, which are only the eyes. And these camera shots, depending on how they're handled, can have implications for the story. For instance, a shot that aims up is called the hero shot. And typically this is given to characters that you want to show have power in a given scene. And the opposite shot is a down shot, which will do the opposite of the up shot, make a character feel in a position of less power. When trying to get the best results possible out of your animation, I like to study film and see how directors put their shots together. One of the best things you can do is think about what real world physical limitations there are for shots that are made. And if you're able to reproduce those in 3D, you won't end up breaking some sort of illusion of reality. You'll notice in a lot of film, directors don't move the camera very much, or if they do, it's extremely purposeful. Too much camera movement can be really jarring and distracting. I'm going to go ahead and do a camera demo in Blender. So here we are in Blender, and I'm going to go ahead and select the default Blender camera from the top right in the outliner, and you can see it here highlighted in the scene. And this is going to be our default render camera. Right now we are looking through the viewport camera or the work camera, and to get a look through the render camera we can click on the camera toggle button, and this is configurable. We can go into the scene settings, and if we have another camera here, we could do Shift A, add camera. It will generate a new camera for us. And if we want to change the default camera for the scene, we can just select it here. So the reason that I'm not able to move that camera around, let's disable our cube. You'll see here it created that camera at the origin of the scene. And when I look through that camera, I go to move that camera around by middle click moving around, and it just pops us out. If we go ahead and look through that camera again, we see there's a lock icon. We can press the lock icon, and now when I zoom out on my scroll wheel and tumble around, we're now able to aim this camera. So if I enable that cube, you can see that we're looking at the cube, and are able to reposition that camera as needed. I'm going to go ahead and disable or delete this camera because we already have one in the scene. And let's go back and double check that it's reset here. Okay, let's now configure some settings for our render camera. I'm going to click through, and so we have by default a frame around our camera, and so this dark area on the outside basically shows you what will not be included within the camera's frame. If we go to our render settings, we can see we're using Eevee, and if we go down to our scene settings here, our output settings, you can see that we have resolution, and this resolution gives us this particular aspect ratio. So if I was to make this 1080 by 1080, you'll see we now have a square. The square is not really something I'm going to be rendering with, so I'm going to reset this to the default value by right-clicking on it and doing reset to default value. Let me go ahead and turn on screencast keys. That way you can see, press the N key to close that. Now you can see the keys I'm using on my keyboard. Okay, so our camera also has settings we can configure. Let's click on this camera settings icon down here. It's in green, and it is the icon of a camera. So we can select a few things. That includes the type of lens. So we have this ability to choose different types of lenses. So we have perspective, orthographic, and panoramic. Panoramic is going to be a special use case lens when we're trying to solve for some technical need to render something in a panoramic way. Typically perspective or orthographic are going to be the two that you use. You'll use perspective most of the time. If you want to have an isometric or orthographic looking render where there is no perspective, that is, things don't get smaller as they go into the distance, you can choose orthographic. By default, the top, left, right, bottom views are all orthographic views. These are great for construction. So when you're building something, orthographic is very useful. And you can see here that there is a grid icon when you're in these views. And this allows you to turn on and off the perspective camera mode, just by toggling that. And this is just for the work camera, not for the render camera. So let's jump back into the render camera. You'll notice that that perspective toggle's gone now. We can go down to the next item here, which is focal length. So this will allow us to have a wide angle lens. So something like a 17 or 16 millimeter lens is going to be really wide. We can get really close to an object, and it'll be fairly distorted as a result. So you can see as we get this object to the edges of our lens, it gets pretty distorted. Or we can go the opposite. Let me zoom out here, or move the camera farther away from the object. As we increase this focal length, it starts to flatten that object out. And this is going to give it a more cinematic feel. That's a pretty easy way to achieve something that feels more film-like. And 80, I believe, is now the new default. Let me just double check if I reset to the default value. Okay, 50 millimeters is the default value. If I was doing something like a portrait render, I would typically do something like 80, just because I really like the feel of 80 millimeter focal lengths, but that's totally up to you. I'm not going to talk about these other items, but clip start and clip end will help you see objects that are really close to the front of the lens. So to show you what I'm talking about, our lens is, our camera is getting really close to this object, and you can see here it will see everything up to 0.1 meters and away up to 100 meters. If for whatever reason you are getting some clipping, so let me just bring this back to maybe 36 millimeter. If I zoom in, we can see we're getting some clipping. This object is disappearing. What you can do is change the clip start, and we can actually make this start much closer to the camera lens. So I added a 0 after the point, between the decimal point and the 1, to make it 0.01 meters. And now we can see much closer to that lens. You can do that with clip end as well. If something is disappearing in the distance, you can add a 0 and it will bring that object into render view of that camera. So depth of field, to show you how that works, I'm going to switch to cycles from Eevee, and let me tumble around. So depth of field is going to help you get that blur effect in the foreground and background. So if we enable depth of field, we will also increase the render time significantly, depending on the situation, but you'll see we're getting blur happening already. Right now it doesn't really know where to focus on. So I can either select an object and it will focus on the middle point of that object, or I can add something like an empty. And so I like to add an empty and snap it to the part of the object I want to have in focus. So in this case, I can turn on vertex snapping, and I will select my empty and snap that empty maybe to this corner here. And I also want to change my focal length. So let's go back to my camera settings, and actually 36 might be, that's pretty good. Okay, so if I want this to be sharp, I need to select that as the focus object from the menu here. So instead of cube, I'll select my empty object, and now you can see it's working really well to get some laser sharpness here on this corner, but the other edges are much blurrier. And that has to do with the size of the object, the focal length of your lens, and the f-stop that you're using. So if I was to increase this, let's say to 5, we're still going to get some of that blurring, and this is because our camera is really close to this object. So the farther we pull this away, it's still kind of refocusing that lens on that object. And now we're getting a less severe blurring effect happening. So there's a couple factors that go into configuring depth of field. You can also configure the blades. This will impact the shape of your bokeh, the rotation, and ratio all have an effect. But for the most part, just adjusting the f-stop and your focus object will be the two primary things that you have to configure. I do want to point out that there's something called viewport display in your settings, and this will give you access to composition guides. And I can actually turn on these guide overlays. So here's the kind of thirds overlay you might have on something like an iPhone camera. We can turn on these center guides, which will put these kind of crosshair, so we can always figure out where the center of our frame is, and that will help us just configure our composition as needed. It probably is a little bit hard to see here in the video. These are really thin guides, but they are there. So you can kind of experiment with different types of composition guides. Thirds generally is going to be the most useful. For instance, you could take an object and just line it up with that thirds line, and maybe with the horizontal thirds line where they intersect, and that's generally going to be a good way to have a solid composition without doing too much work to make a good composition happen. Okay, so that's all I'm going to show for camera at the moment. Now let's talk about lighting. Here's a link to the Blender documentation on lights. Let's talk about some common lighting tools found in 3D software. The first is global lighting, and this can refer to something like ambient or world light, or environment or HDRI lighting. HDRI lighting is a high dynamic range type of file format, and this can help you get the most photorealistic result. And typically, if you need to match, let's say, the lighting of a particular filmed scene, and you need to match that with your visual effects shot, you would have someone on set who can actually create an HDRI from the lighting that occurred during filming that day. And the second category is object lights. Object lights can refer to omni, point, area, and directional lights, and I'll go over more about what these do in the demo. Shader-based lighting can refer to emissive lighting shaders, or shaders that are applied to the surface of 3D objects that will be the source of light. And the second is a reflector that is used to bounce light or absorb light in a scene. I wanted to go over some common light setups. A 3-point lighting setup includes a key light, a fill light, and a rim light. Practical lighting refers to the environment or the scene being the source of light. And so that would include things like lamps, fire, any overhead lighting you might have, objects in the scene like cars that have headlights that are contributing light. Anything the scene produces that will illuminate the scene is called practical lighting. Subject-specific lighting could include something like spotlights in a theater, or a light box that you use for product photography, God rays that come through clouds. You might have lighting that comes up through the bottom. Let's say you have a light table with a bunch of objects on it. And then environment lighting, you might have HDRI for matching the film location, and then you could have a shader that mimics sun and sky environments. Here are some major lighting considerations that will help you design the light within your 3D scene. Direction refers to how light lays on a subject. Size and proximity refers to how close and how large a light source is from the objects that it's illuminating. That will impact things like shadow sharpness and how intense a light will be. Color is useful because it suggests a location and time. For instance, is it a sunset or is it the middle of the day? It can signify or reinforce story concepts or metaphors, and it tends to follow film genre tropes. Readability really refers to whether an audience can understand what they're looking at. Emphasis refers to your ability to use lighting to guide a viewer's eye where you want them to look. Masters painters invented these techniques hundreds of years ago. And so if you really want to be good at creating emphasis within your images or your animations, study the Masters painters. I'm going to go ahead and jump into Blender and do a lighting demo. Okay, now we are in Blender to take a look at how to set up some lighting. By default, Blender comes with this Omni or point light. I'm going to delete that. And if we're going to get rid of this default cube, I want to do Shift A, and we're going to add another mesh type called monkey. And I want to smooth this out, so I'm going to add a subdiv modifier. Let's take this up to 3. I'm going to right click and do shade smooth, and that will make it so that the surface is nice and smooth rather than faceted. Okay, now I want to add a sort of portrait 3-point lighting setup for this monkey. To do that, I will hit Shift A, and we're going to add a light, specifically an area light. Let's go ahead and rotate this. It's going to be a little bit off to the right side. Okay, and just to see what we're doing here, I'm going to enable render view, and I'm going to switch to cycles so we can get a bit higher quality. This is fairly dim, so I'm going to go ahead and adjust the lighting settings. So down here under the light bulb icon with the object selected, we can increase the power. So maybe something like 100 watts. And that's going to contribute a lot more light. You want to make sure your object isn't scaled too large or too small, because if it is too big, you will need way more light to fill that area. If it's too small, it'll get blown out with very little light. Okay, so let's go ahead and look through our camera. Go ahead and click lock so I can move that camera around. And I like maybe something like this, where the object is, or this sort of face is looking maybe off to the right. And right now it's looking a little bit dark. I do want to show you that we have some light being contributed, and that is from the world light, or this background color. In order to adjust the ambient light contribution, we can add or remove value here. So if I take that value all the way down, you'll notice it's pitch black in the shadows. If I make it pure white, you'll notice the entire scene is adding a ton of ambient lighting. I'm going to take that back to the default. The default should be fine for our purposes, but I just wanted to show you that that was there. Let's go ahead and jump out of our render camera. Press Shift D. Now I can go into the top view. We'll rotate that around. So there's a couple ways that I can jump back into our camera. There's a couple ways I can illuminate this side of the object. So I can just add a little bit of light by making the power really low. Another thing I can do is move this light farther away. Okay. There is another thing I can do, which is to not use a light at all. Instead, I can use something like a plane as a reflector. So just to show you how this is working, so I have my plane off to the left, and the default material for the scene is white. So I'm just going to add that here just to show you how this works. But essentially, we have a light on the right, and then it's going to be bouncing light off this reflector to the left. And now we're getting that bounce light here on this side of the monkey head. Just to show you how that works, if we make this a different color, let's say red, now you can see that I am getting this red bounce light contribution because it's essentially getting some of that color information when it bounces back off that surface. So I don't even need a light necessarily to fill in some of these shadows. But the nice thing about a light is that I can really finely control how much bounce light we're getting. Let me go ahead and increase the power, maybe to 50 watts. And if I want, I can change the color of light. Right, so this is maybe now next to a window, and we're getting a lot more blue light coming in. Okay, and another thing we might want to do is create a rim light. And a rim light is going to help separate this object from the background. So if I have a background, for instance, and we have this backdrop, I'm going to add a nice smooth curve by beveling, Command B, and there we go. We're going to use the scroll wheel to add some geometry to that curve. Hit escape, and I will shade smooth. We have this white material. Something like this. We are losing this monkey head a little bit to the background. So that is where the rim light comes in. So I'm going to add, let's try another area light. Okay, let's increase the power. And now you can see a highlight happening here along the top edge. And along the top edge of the ear. I think I want to rotate this. Okay, and our shadow here is a little bit small and sharp. So I think our key light may need to be larger so that we get a softer shadow. So if I increase that, I just want to show you, that has really softened that shadow up. We are getting a ton more lighting now being contributed, so I can dial down the power a little bit, maybe something like 80. And maybe I want to adjust this light on the left. Maybe this blue light is a little bit dark. So if I bring that up to a high value, and maybe we can choose a little bit less intense color, maybe something a little closer to white but still blue, or maybe a warm color like an orange. And I think I actually want to make this one a bit smaller. Let's move it closer, and instead of it having it such a severe angle, I'm going to rotate this something like that, and I think I'm going to rotate that to be pointed up instead of down, so it's sort of lighting from the bottom right or bottom left here. Okay, and then our key light, instead of that being a white color, we could actually make that more of a blue color. Maybe we can bring the intensity up to make that a bit brighter. If you want to see if you're blowing out the image, meaning if you have any hotspots where you're losing color information, what you can do is go to color management and use their utility view transform. So right now AGX is going to be your best quality view transform, but if we do false color, as long as we don't see white, we should be okay. So yellow's getting pretty hot, but if I was to bring this really close, or maybe turn that up to 1,000, you can see the heat map is getting a lot warmer. So if I do something like 10,000, so 10,000 will blow out a significant amount of information. So when you render it, you won't get any of this detail. It'll just be probably pure white or something like that, or pure blue. I'm going to take this back down to 120, and we're going to take that color management view transform off and put that back from false color to AGX. Okay, so that is a classic 3-point lighting setup, and you can kind of dial it in based on where you want your shadows to fall and what kind of lighting you want. You could spend time trying to fine tune it, but just to show you what this looks like, we can go to render and render that image in cycles. And now we can see our final rendered monkey head. I think in this case, just looking at it, I'd want a much tighter, brighter highlight on these surfaces. I'm not going to bother adjusting that now. But some of the other things that we can take a look at include maybe some side lighting. Those are pretty easy. So I'm just going to go ahead and open up a new scene. And we're going to add the same object back. And we're going to add that subdivision modifier. Take that up to 3. Shade smooth. And let's say I want to render this more like instead of a portrait, more like an object, like a product of some kind. I could do that a couple ways. The easiest way would be to add an area light and rotate that 90 degrees. And we can scale that, instead of evenly, we can scale that up to be more of a rectangle. And so let's go ahead and select cycles, GPU compute, and let's configure this to be 100 watts. And let's take a look at the render preview. Okay, so this is just a one-sided lighting setup. We have that a little bit of that ambient light. So maybe I'd want to, depending on the situation, increase the contrast by just removing that ambient light, and now we get that pure black in our scene. We lose a ton of detail, so you might want to add another light to the other side. So let's go ahead and do that now. Okay. I'm going to go ahead and lock my camera, my render camera. We're going to make this more toward the front. We'll have a similar type of setup as last time. Now we can see we're getting this core shadow in the middle of the face. So that's like an interesting effect. Maybe I'll take this intensity down here to maybe something like 50 or 10 even. Or maybe I'll take that up to 150. Okay, so to even this lighting out a little bit, why don't we go ahead and scale our area light a little bit wider so that we're casting more light toward the center of the face. And we can bump up this intensity a bit. And maybe the same can go for this light as well. Maybe we'll move it a little bit closer. Okay, so let's just take a look at an image render for this lighting setup. So you can see it's just a light on either side and no light being contributed from the ambient scene and in the front or the back. Another thing that you could consider if you have a shiny object, let's say something like a phone or a car, this material is a bit rough. So if I take roughness down, we're getting these highlights. So it's more like car paint or a plastic glossy paint of some kind. If I was to maybe bring back our ambient, let's reset that value. Actually, I think default value should be around there somewhere. Instead, what we can do is try to get some long highlights along the top. I'm going to delete this area light for now. Let's have this aim down, and looks like we are getting our default scene light there, so let's turn that off. And let's add this to the top and scale this in the X. So we're getting this long light, and I'm going to duplicate this a few times. Okay, so now what we're getting is this sort of highlight along these curved surfaces. You can take those and maybe move them around while you're looking through your camera. So I actually think I might like something like this more. And so really what I'm looking for is casting light along these curves, which is a more appealing way to light a glossy object. So instead of having these area lights, I can create an emissive object. Let me go ahead and turn these off. Okay, if I was to create maybe a circle, let's edit that and press F to fill, and let's inset this, and then I will delete the middle. Okay, so we have a ring. I can maybe expand that. Maybe I'm going to make this thinner, so I'll just scale this out a little bit like that. And let's add an emissive texture or an emissive shader. And so this basically just contributes light from the mesh. So if I was to increase the strength, let's say to 5, now I can get the effect of a ring light. Let me just go ahead and increase the scale of that and maybe bring it up a little bit. All right, so that is looking pretty interesting. So I go ahead and take our render, we can see what that looks like. Yeah, so we're getting some really nice highlights happening on these curved surfaces. So that looks pretty good. So those are some quick ways you can add lights to the scene. So just to recap, we took a look at adding spotlight or an area light. We didn't look at the other ones, so let's go ahead and add those really quickly. So let's go ahead and add a sunlight. And it doesn't really matter where this object is in your scene. It will always contribute an even amount of light in whatever direction it's pointed. So I'm going to turn off our circle light. And so you can see this is going to have the same effect as an area light on this one object. But if I was to add more objects, let's go ahead and aim this down because it's angled up. Now we're getting something that is more similar to what a sun would do. And we can take this and we can increase its strength and angle. So if I increase the angle, we're going to get this nice soft shadow. Or if I bring that angle down, it's going to cast a darker, sharper shadow. Okay, and if I make this blue, we're getting something that is a bit more resembling sunlight. Because remember, sunlight isn't white necessarily. When it comes to the atmosphere, it tends to be blue or red or yellow, depends on the time of the day. Okay, now let's add a couple other lights. I'm going to add an omni light or a point light and a spotlight. And right now I'm not trying to achieve anything in particular. I just want to show you the differences. So we have our omni light on the right hand side. I'm going to disable that for now. And let's adjust our spotlight. I'm going to disable the sunlight as well. And now we can see we're getting this nice top-down lighting with this kind of cone, which we can adjust the fall off of and the radius of. So if we increase the radius, we get softer shadows. We can increase that wattage to 250. I think that maybe is too soft. And we can increase the size of the cone or the angle of the spot. And we can change the fall off between the light and the edge of that cone to make a softer transition. So now when we look through our render camera, let me back this off. And let's take a render here. We can see we're getting our sort of stage spotlight. I think I'm going to bring that spotlight size down. Okay, we're getting a bit of a weird reflection in the middle of that head, so I would probably move this and continue adjusting, but this is how you can get a spotlight pretty easily. An easy way to get a ray of light would be to add a volume to the scene. That's going to really increase rendering time. But if I go to the shading tab and I go to world, I can add a volume shader, principled volume. Let's plug that in, and we're going to take density to 0.1. And our light isn't going to be nearly strong enough. Let's do density of 0.05, and we're going to increase this to 1,000 watts. There we go. So what is this doing? So if we do a render, the render is going to take a little bit longer, but now you can actually see that cone, that light, interacting with a bit of atmosphere. And that's a way you can actually render a ray of light in the air, essentially. So you're adding that volume to the entire scene, and it's sort of air density in a way. So if we were to increase the density, it's going to interact, and we'll have to increase the amount of light we're contributing. If I do 2,000 watts and we increase the light density, 0.1 should be fine. Let's go ahead and do another render. Okay, so now that is showing up a little bit better than before. I'm not going to wait for this to continue. Another thing that we can do is add our point lights. So a lot of times you'll see in 3D animated films to make up for the fact that they weren't able to get the correct lights just from the practical set that they had set up, they will take a bunch of point lights and just fill them in as needed. So if the camera is right here, they don't really care that they're spilling light over to the left because it's not going to be in frame. But they'll just take a light and then color it the color that they need it to be. I'm going to go ahead and put this roughness back, and we're going to make this desaturated so we can see the effect of the colored light. So this light so we can really take this out of our typical everyday lighting and paint whatever colors we want. And omni lights, or point lights, I should say, are just really quick methods of doing that within a scene. So I was trying to have 3 lights and I accidentally got rid of one. So there we go. Now we can see we have all of our different colored lights. We probably want one in front as well. But that's essentially how your point lights are going to work. Now let's talk about rendering. Here's a link to Blender's render documentation. Blender comes with 3 main render engines: Eevee, Cycles, and Workbench. Eevee and Cycles are going to be the 2 primary ones that you will be working with. I'm not going to cover Workbench. It's really not used for rendering images or animations. It's more of a tool for when you are working within the software. So Eevee is a raster-based render engine, and essentially that means it's sort of like a game engine or a real-time render engine. And this can be really useful because you can figure out what a scene is going to look like really quickly within Blender. It doesn't require you to wait around to see what the final render is going to look like. It also is really advantageous when you only have maybe a laptop to use when rendering a long animation. Something like Cycles or a ray trace or path traced render engine will take a lot more computational power. It has a couple disadvantages. 1, it's not going to be as accurate, and 2, it might not look as good as a render you could get from Cycles. So Cycles is Blender's physically based path tracer render engine, and this is what you're going to use if you are making something that's cinematic in quality. It is able to do things that aren't necessarily photoreal, so you can do non-photorealistic rendering, sometimes called NPR rendering. And you can also get really high quality photorealistic renders and a high degree of accuracy. The downside is the render times are going to be longer, and you'll have to wait around for it when you are building your scenes to see what they're going to look like. The faster your graphics card, the more you're going to get out of using Cycles as your render engine. Let's jump in and do a demo in Blender of Eevee and Cycles render engines. All right, let's take a look at the difference between Eevee and Cycles. So under render settings here, we can see the default is set to Eevee. If I click on the rendered viewport shading mode here on the far right, we can see that we get some lighting that looks better than solid or texture space lighting. What we can do is create another light here, and then we can get more even lighting on this object. If we go ahead and configure our render camera. I'm going to go ahead and also add a plane. So let's scale that up and move it down. And now we can see this object is sitting on the plane. We're getting two shadows. That's not always appealing. You can cheat in 3D software. We can just eliminate casting shadows if we want from one of the lights, and now we're only getting a shadow from one light. That's not accurate or realistic, but you know, that might not necessarily matter. What I can also do is go back to our render settings here and go down the some of these other settings. For instance, ray tracing will bounce light. Just to show you what that looks like, I'm going to make this material red. Okay, so we're getting a little bit of red contributed. Eevee doesn't really do ray tracing traditionally, so this is a new feature for recent versions of Blender. But what we can see here is that when we turn on ray tracing, it's going to bounce that red light up onto that object. So that's going to look much nicer. This is more in line with how Cycles is able to bounce light around a scene. I'm going to go ahead and go down to our light settings and turn on shadow again. And what we'll do is move that light. Maybe we'll move this light here and cast it over there. Okay, so let's go ahead and render out an object. I'm going to remove our default cube. Let's add a monkey and a subdivision modifier. All right, and we will shade that smooth. Okay, so now we're getting nice light bounce. I will just go ahead and also set up a backdrop to make our render more appealing, where I extrude out this back wall and press Command B to bevel. I'll pull my cursor away and use the scroll wheel to add some subdivisions. Okay, press Tab to get out of edit mode, right click and do shade smooth to smooth out that back curve. Come back in and align our view. Let's disable one of those lights, casting shadows. Okay, let's just render this and see how it does. Okay, so the render, you can see, took 1 second, just a little bit over to render. Now what I'm going to do is choose a slot, an empty slot here, and we are going to switch to Cycles and see how long that takes to render the same thing. I'm going to leave this in CPU. Just for an example, we'll probably have to cancel this. Let's go ahead and start our rendering. Okay, you'll notice that at the top it's counting samples. We have 4096 set in our render settings. It's only up to 33. This is going to take a long time to render. It looks like it's estimating 15 minutes. That's way too long. So I'm going to go ahead and cancel this. Instead, what we can do is switch to GPU compute. If your computer is compatible, come up to Edit, Preferences, and under System, you can select your video card if you have a compatible video card. If you do, now you can take advantage of GPU compute, and just at the default render settings, which are fairly high at 4096, we can click Render Image, and you can see it's starting to go up to that same 4000 sample count, but it's going really quickly. So instead of taking 15 minutes, it took 11 seconds. Just to compare this render with Eevee, I'm going to just go back and forth here between them, and I'll zoom in. So this is Eevee, and this is Cycles. You can see we're getting a lot more accurate light contribution to our render as compared to Eevee. Okay, let's say you don't have a graphics card that is compatible or fast. You have to use CPU compute maybe. What you can do is now dial in these samples. So let's say something like 120 samples is more reasonable. That's pretty low sampling for a final production render. I'm gonna uncheck denoise. Let's go ahead and disable noise threshold. That will lock this in at 120 samples. Let's go ahead and click render. And you can see it is now rendering with the CPU. We're at 21 samples. It has to go all the way up to 120. So we'll see, should be there in a few more seconds. Okay, this took 27 seconds to render with the CPU. Zooming in here, we can see a little bit of noise. So if I was to change between slot 2 and slot 3, so slot 2 was with my video card at over 4,000 samples, and slot 3 is 120 samples. Definitely pretty noisy. We're getting some very obvious noise in certain parts of the image. What we can do though is check this denoise property, and let's say 120 still took too long. We can drop this down to something like 64 samples, and let's go ahead and choose an empty slot to do our render, and we will kick off this render. Remember, we set this to 64 samples, and it will do a denoising pass at the end. Okay, it looks like it will take a little bit less than last time. So at 16 seconds it completed. Roughly a little more than half the sample count, but you'll notice it looks better, and that's because we added a denoising step. So this is actually what 64 samples looks like. But with the denoising, it gets rid of all of that noise for us. So when we compare 64 samples with denoising to our super high sample rate, so I'm going to zoom really far in here if I can. So this is our really high sample rate, and this is the low sample rate with denoising. Not a lot of visual difference. And certainly nothing I could really point to say which one is higher quality. So, just be aware that you don't necessarily need to have the most samples to get a good image. You can use the denoising feature with low sampling and still get a really fast render time and a fairly high quality image. It really depends on the scene itself. This is a pretty simple scene, so you might not necessarily get the same results. I'm just going to look at the shadow here and see what that looks like. So we're actually getting pretty much the same shadow information as well. So that's a really good kind of example of how you can optimize your scene if you don't have a really expensive computer, for instance. And that was a quick look at the render engines available in Blender. This concludes the lecture on camera, lighting, and rendering.